So today we took a drive out to Palo Alto, and more specifically we are heading to the Los Trancos Open Space Preserve, and we're going to be walking along the San Andreas Fault Trail, and we'll be gathering a lot of information today about all of the effects that came with the San Andreas Fault. And before I get started on my hike, I'm going to give a little background information of the San Andreas Fault. And I got my source from sanandreasfault.org, and what I gathered from that website is that the San Andreas Fault stretches roughly around 800 miles throughout the state of California, and it goes in a north to south direction. And the San Andreas Fault is the cause of most of the earthquakes that came throughout the state of California, and it can reach at a high point of an 8.1 magnitude, which is why we've seen a lot of tragic earthquakes throughout the past couple decades. And also about the San Andreas Fault is that it's where the North American plate meets the Pacific plate, and that's why it's considered a fault, because a fault is where two plates meet together. So yeah, here we go. So right now I'm walking along the trail that's considered the San Andreas Fault Trail, and we're just trying to get to the different locations that you could see more clearly of where the effects of the San Andreas Fault had in this area. While I'm walking, I'll give a little bit more information of what we can look for while we're out here. And we could look at the Sag Pond, the San Andreas Lake, and it was created because of the San Andreas Fault. That's why there's a Sag Pond. And also a lot of San Francisco gets some of their water from this Sag Pond, so it's pretty important for the area to be here. And also in the surrounding area, there's also Black Mountain, Page Hill Road, and we'll be able to show more when we get to those locations of the different effects. Stop on my hike is I came across a fence, and according to www.openspace.org, it states that this fence was reconstructed from different pieces of wood that was found throughout the preserve, and they wanted to make it look like how it would after the earthquake hit in 1906. It's just to get a general visual of it, and so I'm going to show you what the fence looks like. And if you could see it, it just looks like a normal fence going down the hill, but then if you come over here, here's the fence, and then there's a sudden break, and there's an open space right here, and then here's the rest of the fence that goes uphill. And the reason that they had reconstructed it to be like this is because to get a general idea of the shifting of the plates when the earthquake hits, and it leaves a lot of the area split, which is why you find the open space and the different location of the fence. What I wanted to show you is when I was on my hike, I found these two trees that were growing pretty oddly versus the other trees that you usually see. And the reason for this is because during the 1906 earthquake, all of the shaking had caused these trees to kind of collapse, but it was able to save enough to where they didn't fall all the way to the ground. So ever since then, the tree continued to grow, and that is why you see that trunk is going more at a parallel vertical direction rather than straight up and down. It's because of the shaking from the earthquake in 1906. A little information of these different locations is the Loma Prieta is located on the American plate, which is underlying most of the North America and half of the Atlantic Ocean. Where I'm actually standing right now is considered to be the eastern edge of the Pacific plate. It's kind of hard to see exactly where, but in this general location of where I'm standing would be considered the eastern edge of the Pacific plate. And the San Andreas Fault, it's actually located along the Stevens Creek Canyon, which I had mentioned a little bit ago, which is also the boundary that's between the Pacific and the American plates. I just wanted to point out a little fun fact that if you're on this hike, you're able to find some clues about when you're in a fault zone. And one of the clues is a shallow but significant depression that is below. And it's also called a sag pond. So when you find yourself in one of those, you know that you're dealing with being in a fault at the moment. So I'm walking on my hike still, and I have just recently crossed over the main fault again. And what we had came up to right now after crossing is a sag pond. And a sag pond is a body of fresh water that's collected at the lowest parts of the depression formed between two sides of an active strike slip. And I'm going to show you. If you look, there's no water right now, but in the cooler temperatures and the different parts of the season, there'll be a little pond here which will start flowing the water, and it'll go down there. And I don't want to get too close because there's poison oak all over the place. So yeah, that is just a little information on the sag pond that I just came across. So as I'm continuing on my hike, I noticed that there was a lot of willows and brush that were in this one specified area. And what it mainly specifies is that there's more water in this area than there is in the other parts of the preserve. And what happens is that as the faults move, the rock in the fault is created into a clay, in a sense, which is considered a fault gouge. And what it does is it kind of barriers for downfall of water. And as you can see, this is where there was a previous landslide. And at the end of the landslides, it'll hit the clay at the bottom and it'll begin to bubble up. And when it starts bubbling up, that's when the springs and the different wet spots are formed. A feature that I wanted to take a look at are these large rocks, which would be considered like boulders, that I step around during this trail. And the type of rock that it's called is a conglomerate. It's a sedimentary rock, and it's made of round pebbles. And it came from flanks from the Loma Prieta. And what's crazy about it is it's 23 miles away. And yet here it is, getting formed along this trail. So right now we're driving down Page Hill Road, and it's hard to see when you're driving by, but when you look along the road, you see a lot of cracks, and then there's some dips in the road, and the cracks are filled, but you could still see them, and those are all contributed from the San Andreas Fault.